So, hello everyone. My name is Nikolai Kondrashov, and I will be speaking about user session recording, which is basically meant for use on critical systems, on sensitive systems, to record whatever users do, whatever users access, whatever users run on those systems. So, I come from Finland. I'm originally Russian, and I moved to Finland 5 years ago. And now I'm working at Red Hat in the identity management group. I'm helping SSSD. I maintain free radios packages, and I mostly focus on this topic, on user session recording project. In my free time, I founded the Digiment project, which works on improving Linux support for generic graphics tablets, which are not Wacom, but still graphics tablets. And I still maintain it, and also I also try to study electronics and embedded. So, has anybody of you been recorded before? Let's see. You were. Oh, there is one person. One person. That's interesting. That's the first. Has you ever set up recording yourself, recording of somebody? You did. Great. If you didn't, do you regret you didn't? Any of you regretting it ever? Okay, there's one person. Okay. So, we've been doing this identity management thing, which is free IPA and SSSD, for quite a while now, and it's gotten pretty good. So people started migrating to it, and people who previously used commercial solutions like Active Directory and some other solutions, they started using it, and they noticed that it works pretty well, but they still have one of the essential parts missing, which is session recording, which is mandated often for medical organizations and financial institutions, and sometimes required by law. So people basically need to see and to know what their contractors do on their systems, and when something happens, they need to know who broke the system and how they did it, how exactly they did it, and what was happening. So basically, the companies and the government, they want to have everything recorded ideally. Whatever the user does, if they could, they would put a camera behind the user's back and see what was going on. And I guess there are some installations that do that. But essentially, yes, they want everything recorded. They want it stored somewhere safe, and nobody except privileged persons could access it. And they want to easily find who did what and when and what was going on and how exactly they did it. So they want to see what was actually happening. So there are a lot of commercial offerings for this, and they go from dedicated hardware which you can buy and put in front of your servers, and it will intercept secure connections provided you have the keys, and record SSH sessions and record SSL database connections and everything. There are jump servers that you can install also on your own hardware, or you can install software directly on your target servers, and it would act as a partially kernel space solution to intercept data and send it somewhere. They record keystrokes, they record processes executed, they record URLs accessed and applications started, and these solutions often work. They are often offered both for Unix, Linux, and Windows. And pretty often they are also integrated with identity management solutions, and they often come with, third-party identity management solutions, not necessarily those that come with your system, for example, on Windows, because some people want to unify that across Unixes and Linuxes and Windowses. And they also have access controls recordings and management of central storage for the recordings and searching and analysis. And of course the playback. So yeah, there's lots of solutions, but they are pretty expensive and sometimes they involve pretty involved and cumbersome licensing terms like licensing per server, licensing per user, etc. Which is, well, people don't like that, paying money and a lot of it. And then you can fix it yourself and you can't improve it because, well, the source is closed and you are relying often on just one supplier. And if they screw up, you can't do much. So, of course, the ideal situation would be having access to the source code and being able to look inside and being able to see what's going on and fix it and at least understand what's going on so you can try to fix the problem while waiting for the fix, somehow work it around. And of course, people want support, especially enterprises. There are existing solutions which people use, and actually we at Red Hat build for customers, like using script and building a jump server with SSH access and some area where you put files and before they get to the target system, so that is recorded. And but it is all do it yourself, and it takes a lot of time and maintenance. So you can do script, the basic tool, which is completely not security oriented. It doesn't have any protection for the recordings, and you can do it only at your own will. And you can do what, like, if you want to record yourself, you can use it, but if you want to record somebody else, you need to go to great lengths to protect the recording. There is the sudo IO logging. It is security oriented and it works pretty well, and you can search it. You can play it back on the terminal, but it doesn't have anything to support getting the recording of the system. And as far as I know, while the session is recorded, the file with the recording is incomplete and you can't stream it. So with sudo, you can only record the file, record the session, and then get it off the system with rsync or something. Then there is the closest thing that exists there is the TTY audit. And it's a subsystem in the kernel kind of attached to TTY where you can request logging all the user input to audit log. And it's pretty good in that you can send these logs somewhere where it can be kept safe and pretty fast, but it only records input. So what we're trying to build is, well, what the users ask. So and they need the data that you enter, the screen that you see, and what you execute again, and what you access. And you need to get it off the machine as soon as possible and store securely. People also ask to be able to search for particular events that happened, like you can search for the commands executed or search for particular text that user entered or saw on the screen. And they want to correlate that with other events that happened, I don't know, some server crashing or some stack trace appearing somewhere or access logs or something. And they want to be able to see the recording, not the recording, but directly the session as it's going on, in case they want to catch something as it's happening. And most likely it's not going to be a human, it's going to be some machinery that just watches that stream. And when something happens, they of course would like to see what happened. And they want, again, the central control where you can set, like I want to record these servers, on this farm, I don't want to record those servers, I want to record those user groups. And they want to also control the access to the actual recording as well. So TTY audit already does it with logs, and we thought that perhaps going with logs would give us a lot of benefits. We already have the delivery system. We have audit logs which record those accesses, those files, those processes executed. And we have a lot of solutions to analyze these logs and to correlate them. So we were trying to decide what we can use for the analysis and for correlation, and we wanted something, of course, open source, as we want everything to be, and we wanted something that would scale to the enterprise level and that would have all the features that users are expecting. So the current, the hippest solution right now is Elasticsearch and Kibana, with Kibana possibly replaced with Grafana or some other tools, but basically Elasticsearch is the king of open source solutions. And we at Red Hat actually are working on a project currently called VIAQ, which is a working name, which is trying to build a solution for Red Hat products where you would be able to set up Elasticsearch and forward all the logs, normalize them, and then correlate them. And normalization means that that this solution would take the basic fields that you need to start correlating, like host names, timestamps, usernames, etc., and it would put them into fields that are named consistently, which you can expect to see in the logs. There was a previous effort which was called CEE, which tried to completely normalize all the logs, and after several years of effort, they basically gave up. And this approach that we are trying to take is a moderate approach, if I can say so. And we already got that working on OpenShift, more or less, and it's going to OpenStack and possibly some other Red Hat products. So next, so we need to, from that list remains the central control. We need to record what users enter and see, and we need to make sense of audit logs because audit logs are plain text. We need to get them to Elasticsearch, and we need to make them searchable, and we need to be able to look for exact data that happened in audit logs. Then we need to deliver it to Elasticsearch, and then we need to play it back. So for central control, we would naturally choose FreeAPA because it's a full-featured identity management solution, coupled with SSSD, which allows you to do things like log into your system even if it's away from the domain controller. And we are currently working on adding session recording support to SSSD, and it's getting pretty close. So for logging input and output, we developed a tool called TLog, which basically goes between the terminal and the shell and records everything that passes between, converts it to JSON, and logs it to syslog. And it already saw 3 releases. It's still not completely production ready, but it's pretty full-featured. And we are doing things with it quite a long while. Next, about the audit logs. We built another tool which allows you to convert the audit logs single shot if you'd like, or you can put it under AuditD, which is a AuditD plugin manager. where it receives the events among other plugins and converts them to JSON again, or to XML if you'd like. And it sends that to syslog at the moment. And we are working closely with the audit team in trying to make this tool produce output which is as close as possible to the original logs in structure, so that people who want to convert audit logs to their own systems, like they can have already a big XML pipeline for converting those logs and for storing them as required by regulations, and so that they can use this tool to simplify conversion, so they don't have to parse the logs themselves. So this already has one release and it's available on GitHub. For delivery to Elasticsearch, we already have rsyslog, which supports that. We have it in RHEL and Fedora, and you can of course install FluentD or Logstash, which also do that pretty well. And the common solution, which is VIQ, which I told about earlier, could also be used for that. So we already have a terminal playback for the data that was sent to Elasticsearch, the user input and output. But we are working on a web UI which would allow you to control it better, rewind it, and look for special strings, for example. Like you can search for a command, and that would give you matches. So you can click on a match, and you would see the logs at this moment. And also the playback in the terminal would rewind to that point, so you can see what was exactly happening. Or you can search what was user entering, or what was on the screen, and it would also rewind the logs and sync everything. We are trying to build it as a reusable web UI component so that you can use it in your own management solution and connect it to Elasticsearch. So a basic scheme is this. Basically, we have T-log recording input and output. O-shape converting ODD events. They are joining in the logs, and you can use any combinations of rsyslog, Logstash, or FluentD to forward that data to Elasticsearch. From there, you can view it in Kibana or in the upcoming web UI. So we think that this approach is actually better than many commercial offerings in this regard, that you can reuse already existing login infrastructure, and you can save resources, meaning hardware resources and existing hardware resources, and you don't need to add that much new capacity, and you don't need that much maintenance compared to a separate system which has its own delivery mechanism and its own maintenance protocols. This also allows you easy correlation with other logs compared to a system which lives on its own, where you might go to the effort of finding the recording, noticing the timestamp, and then going to your logs separately and then trying to correlate that. And you will be able to easily see what's going on actually at the same time. Even though some of those commercial offerings, they offer some events that happen at the time of recording at a specific time, they are not as flexible as correlating all the logs together. So I'm going to show you a little demo. In this demo, user which is recorded will log in to a system. I will start playback of the user session at the same time, and playback will be going, the recording will be going to Elasticsearch, and playback will be happening directly from Elasticsearch at the same time. I'll do some work in the terminal, and then we'll take a look at the logs, at the raw logs in journal, and at the logs as they can be seen in Kibana. So So first thing I'll do when I log in into the system, I will note the session ID, the audit session ID, which is unique for every login to the system. And I will use that session ID to look up the messages in Elasticsearch. So this is session ID 5, and we are, oops, yes, and of course, minus, let's see, 3 hours. I'll try that again. Okay, so we are leave. So on the left is the original session, and on the right is the recording that's being played back at the same time. So let's try for the start just doing a sudo command, and we'll enter some bogus password and fail. Just some output. Or interactive editing. Just to show that everything is preserved and you can see exactly what was happening. Or something fancier. And then we end the session. So I need to terminate the playback explicitly because it doesn't record the end of the session for now, mostly because sessions can end without warning. So let's see now how this looks in journal. So there are some messages here from tlog, which represent the user input and output and timing. If I can highlight them better, perhaps. So these two top lines are coming from tlog, and you can see that it's not very readable. But we'll get back to that in Kibana, where it will be easier. You can also see converted audit messages already in JSON coming from O-shape, and they're slightly more readable because it's basically text, structured text. So all this O-shape and tlog gets sent to Elasticsearch to separate indexes, and in Kibana they would look something like this. Right now we are looking at audit logs, and we'll try to see the processes that the user executed. So these are all exec.vcs calls that the user executed here. We we can find our PS command. It has lots of data about what happened. Or our win command, and you can search for specific commands. Yeah, here it is, the MC that we ran at the end. Now if you take a look at the actual user input and output, you can also search it for, let's say, sudo. And we can see, let's start with the first one. We can see where the sudo prompt appeared. Then the next message was another sudo prompt, and another sudo prompt, and then the message about incorrect passwords. Any questions about the demo? Yep. Yes, actually, the question was, can you see the shortcuts the user used? Well, you can find that in the text, in the logged messages. It will be exactly as the terminal received them. So you have to search for specific control characters that the terminal received, but you can find that. And in the perhaps in the web UI, we can add an option to display these shortcuts somehow. I'm not sure if that will be very reliable, because you get the messages, you get the characters from the kernel, which converts them, which are converted from keystrokes, and you can only extrapolate that. But you can kind of try to find that. Any more?
Let's use a mic.
Hello. So I'm not very familiar with audit D. So what constitutes an auditable event? Is it just any command that is being entered into the terminal, or what is it exactly?
Oh, sorry, I can't quite hear you well.
So I'm not familiar with audit D. So can you just briefly explain what an auditable event is? Is it any command that you enter into the terminal?
So the question was, how does audit work? Audit D works, and what kind of data it logs? Is that right? So audit subsystem is basically a big number of hooks in the kernel, where it is intercepting syscalls and events that were happening, like the particular actions that happened in the kernel, and then logs that through netlink interface to user space process. And the data available can be basically those syscalls and events like somebody's logging in, logging out, and not only kernel can write to those logs, but also user space like PAM or sudo. And there is plenty of data about what's happening, mostly related to security. Like there can be events, for example, like renaming a disk volume. Whatever you can expect that it would be necessary for tracking events in the system, security-wise, that will be there. Okay, so I will leave some time for questions at the end. And for now, next is I'm going to tell you how this works. So the basic process how tlog is started and how it records is the user. We will take an example of login at the local console, which is handled by a program called login. And what login does is it verifies user credentials using PAM. And then it retrieves the shell that it should start, if the credentials were correct, from NSS. And this is where we configure NSS by putting, for example, by changing, for example, passwd file. We say that this user will not use bash or other shell. We'll tell it that user is going to be using tlog as the shell. So login receives that information from NSS and starts tlog, which retrieves the actual shell to start from its environment or from its configuration, and then starts that shell under a PTY, which is a pseudo terminal. And it intercepts what is going between that pseudo terminal and the actual terminal and logs that. And that was the most basic case, but this is what we are planning for SSSD. Since SSSD has modules in PAM and NSS and can control what goes in and out of there, we can do this dynamically. And for the start, we are doing local configuration, where in local configuration of SSSD, you can write, I want to record these users, I want to record these groups. And when login accesses NSS to receive the shell, SSSD will check if the user matches that shell, matches that list of users or that list of groups, and then it will say the user shell is tlog, not the actual shell. And when login sets up the session for the user to log in particular the environment for the user, SSSD can again check if that user is to be recorded by matching usernames and group names, and it can put the actual shell to start in the environment as an environment variable, which will then be picked by tlog when it's started, and tlog will start the actual shell. And then it's proceeded again, PTY, actual shell, passing the data over between them and logging that. That's the plan for SSSD integration. The further plan for pre-IPA integration, for identity management integration, is to have something like what we already have. We have SEL Linux configuration where you can assign host-based access control rules, HBAC rules, to SEL Linux maps, and then SSSD would download applicable maps locally and match them for specific users and implement them. But in this case, in the case of tlog configuration, we would basically store tlog configuration JSON in directory and also do matching on the local side and provide the tlog with configuration over environment. So tlog can be configured to record input and output and window resizes, which actually the last part is not not everyone does that. Usually window resizes are not logged and you are restricted to that. We are not yet supporting that on playback, but in the web UI we will be observing the window resizes and resizing the UI appropriately. There is a configuration for the notice that you're supposed to display before starting recording, and if you really want to, you can remove it altogether. Then you can choose to write to syslog or file, and you can also choose to, if you want the recording delivered with low latency, very fast, or if you want to save on overhead of all the syslog headers and the common fields that tlog logs and tell it to log big messages. And there is already a tool to play back from Elasticsearch, as you saw, and from file, which is useful for debugging. It's a couple words about the schema that is used for encoding the session. So we have to chop the stream into messages, into discrete messages, because it's log. You can't just write there indefinitely. You're supposed to log in chunks. And we store input and output in separate fields so that you can actually search it, because if you store the stream as it comes from the terminal, just as it goes, you will have them mixed all together. For example, when you type a command on your shell, in this case you would receive 2 characters for each character you typed, for the input and for the output. So to be able to search them, we store them separately, similarly how sudo IO recording does. Of course, you can output anything on the terminal, but JSON has to be valid, and being valid means having valid UTF-8 in JSON. So we have to handle somehow binary data, which is invalid UTF-8 in JSON, and we encode that separately as a byte array, and perhaps we'll change that later. But we will preserve binary data always. And we store also millisecond precision timing. When you type, everything is preserved, how fast you type and what you did. And then, oh yes, the window resizes as well. They are preserved with timing. And the schema actually is done in a way where if you want to, you can, after login already, after you stored everything in Elasticsearch, you can go over those messages and combine them into bigger messages, or even combine the whole session in a single message, or in a single Elasticsearch document. Our shape, it works simpler than tlog. Basically, if you stream in, it runs as ODSP plugin, and the chain goes from kernel, where it's feeding the log messages through netlink, to auditd, which feeds binary data to ODSP, and which formats the actual audit log messages, which is then fed to OShape and converted to JSON and passed over to Elasticsearch through Fluentd, RCSLog, or Logstash, whichever you prefer. So as I already said, we try to keep the structure as close as possible to the audit structure, and both JSON and XML are kept similar, so it's easier to reason about them. And we preserve both the raw audit fields, like user IDs, and we add also the interpretation, so-called interpretation, like converting user ID to username locally, because it might be late if it's already on Elasticsearch to convert anything, because you don't have access to user databases and things like that. Apart from actual parsed audit data, we also preserve the raw text as we received it, because some regulations might require it, and it's useful for debugging. And as the next step, we are planning to add so-called audit normalizations. It's a new feature which audit works on, where semantic information is extracted from audit messages and represented as a triplet of subject, action, and object, where it would record this subject, this particular user tried to write as an action to this particular file as an object, and with this result, success or failure. And that data allows for very interesting visualizations of what was happening, which actors existed on the system, and what they did, and or vice versa, who acted on this specific object and when. And this also allows formatting human readable messages compared to raw audit data, where you would see an actual event easily. And we plan to use that in WebUI. So here is an example. This is heavily trimmed. As you saw, there's much more data, but this is easier to grasp. Okay. So for T-log, we still have to deal with recording passwords, because even though by default the input recording is turned off, if you turn it on, it will record everything. And there is a bit of a difficulty in excluding passwords, and PEM-TTY uses this approach of detecting when the echo is turned off and it stops recording. But that is, of course, not secure. But on the other hand, there are many, many more ways to avoid being recorded. For example, you can upload a script and then name it as a common command, which doesn't raise any flags or anything. And then 2 weeks later, you can execute it. But that's why we need audit logs as well, where the actual executed commands and the actual executed processes are recorded. We also need to detect when we are running on the graphical session, because the graphical sessions also get one session ID. And that means that all the terminal emulators that you open will get the same session ID, and there is basically no way to distinguish them. So we need to detect that and stop recording and leave recording graphical sessions to other software which records graphics, which is work for future. And we need to support converting terminal character encodings, because some people still use other encodings except UTF-8, and that involves its own difficulties like invalid characters, etc. So for our shape, there is a problem in that audit log is a big mess. Nobody knows what can appear there, exactly, even audit developers. They have long history, and even the audit developers are not able to reproduce some events that are supposed to happen. And we somehow need to make it, make a schema that it will be reliable, and so people can parse it and can actually use it. And again, the character encoding conversion. So the latest plans is to try to get the first web UI working in Cockpit project, which is a server management UI, mostly for Fedora, and well, also for RHEL. We are planning to basically just record local sessions, store them locally, and let you play back in the Cockpit UI in the terminal emulator. So it's easy to try both T-log and OShape. You can download release RPMs, which are very fresh. I just did them 2 days ago. Or you can build it yourself. The dependencies are very short. The list of dependencies is very short. And you can log and play back to and from file and to Elasticsearch. And there are the instructions for setting all of that up are in README. OShape is even easier. There's just one dependency. Instructions are also in README. And you can just take your own audit log, which you have on the system most probably, convert it, and see how it looks. Okay, we have 5 minutes. Any questions? Yep. Go ahead.
So it wasn't very clear to me how you did the replaying of the sessions. It seemed to me that you were sending some of the inputs when a certain buffer was full, but not delineated on commands. Is that correct? Or which gave a really smooth experience when you were doing the replay, the instantaneous replay. But I'm wondering whether that doesn't compromise searchability.
Yes, the searching. The question was: does the recording actual input and output, is it really searchable that much? Is that the question? Because there is. Yeah, it's. I would say that recording actual input and output is more of an illustration of what actually happened. And the main logs are audit logs. if you want to search for something exactly, you should search the audit logs, which will be both of the both of the input and output and audit logs will be searchable through the same interface. So the recording of the screen and the input is needed to make it easier to understand what's happening, but it's not the authoritative data. It's very easy to spoof things in there, but it helps a lot if you have that.
So as this is more thought about corporations, is there any ETA for Red Hat Enterprise Linux support?
Well, the question was, is this going to be supported in RHEL, in Red Hat Enterprise Linux?
Is there some kind of roadmap or timeline when it's going to be integrated there?
Yeah, the question was, is there any timeline for inclusion into Red Hat Enterprise Linux? So far, I can't promise anything. We are working on Fedora right now, so T-Log is in Fedora, but an old version, I'm going to be updating it there. And Shape, actually there is a question of how Shape will continue, whether it will be a part of audit-D or whether it will be a separate package. That will depend on actually what customers and users want, how they perceive the usefulness of it. But eventually it will make its way into Fedora, and I expect it is likely that it will be a part of Cockpit in a way, as I said, and that means Fedora. But the ultimate target is, of course, getting this to RHEL and making it usable not only as part of a huge, for example, that VIQ project where you are supposed to have OpenShift and all the login setup and everything, but also usable in smaller setups and not necessarily in RHEL or Fedora. It can be Debian or anything. So yes, the ultimate target is RHEL, but I can't tell you the exact dates.
At the end of your presentation, you, in the section Try It, you told about two tools, T-Log and AU Shape.
Yes.
And is it included in the Red Hat distribution, or it maybe will be?
The question was, is T-Log and Shape included into Red Hat distributions? Not yet. You can download RPM packages and try that. They have packages for RHEL and they have packages for Fedora, several versions. You can easily try it, or you can build it yourself. But ultimately, yes, it will be in RHEL and in Fedora. Any more questions? I have Finnish candy here. When we are over, I know that FOSDEM is almost over. Come and take some candy. It's good. Thank you.
Thank you very much. Very interesting.
Thank you.